Hi, I'm Anna Jordanis.
Ciao, I'm Fabio Bacca.
你好, my name is Caroline.
Selamat pagi. My name is Dr. Palni Ramaswamy.
Hola, my name is Fernando Otero.
Hello, my name is Janine.
Γεια σας. My name is Michael Kamburidis.
Hello, I'm Yang Te.
Here at the School of Computing in Medway, we have a team of great researchers that are working on projects that are relevant to society today, yet which will define the world of tomorrow.
So I work in computational creativity, that's my area of research.
I do research on all sorts of sensors. For example, the body sensor you can wear on your scalp that is measured to measure your EEG data.
My main research is data mining. I investigate different techniques to extract useful information from large quantities of data.
My research includes working with intelligent algorithms that I then apply to complex problems from the fields of business, economics, and finance.
My research area is in biomedical signal processing, specifically analyzing signals from the heart and signals from the brain.
My area of specialization is distributed systems and in particular stream processing systems.
We're also working on machine hearing, which is giving computers the ability to understand the sounds that they hear around them.
An example of some work that I've done is with musical improvisation, so free jazz improvisation in particular. And what I did was using genetic algorithms, which is where you can involve different musicians that are particularly better than the others, and you slowly evolve these musicians over time. And so in this case, we had a whole set of computer musicians that were just playing random music. And over time, they evolved. So the ones that were producing the better music, the more creative music, were the ones that survived and evolved and then led to other ones.
I investigate different techniques to extract useful information from large quantities of data. So for example, we can analyze clinical data to improve the diagnosis of disease and overall improve the healthcare. Another example is social media data. So, as you know, social media holds a large amount of user-generated data. So an analysis of this data can detect trends in the wider society.
Brain research has a large social impact. For example, we are currently doing epilepsy-based brain research. That is to actually model and predict the onset of epilepsy that can potentially save thousands of lives. Mental fatigue is another aspect of my research. You know, with our high pace of daily life, we all come across mental fatigue. So how to understand mental fatigue, and especially mental fatigue and physical fatigue, the difference between them and the interaction between them is another area.
This is an electrolarynx. It's the #1 assistive technology for people who've had a damaged or removed voice box, like laryngectomy patients. It allows them to speak in public. Without this, all they can do is whisper. What we're doing is using handheld computers to capture their whispered speech and convert it into more normal speech so they can regain the power of communication in their daily lives.
I work a lot with the stock market. So what I do is look into past data, historical data, and I try to identify patterns on those data. Based on those patterns, I can then build trading models, trading strategies that I'm using to play in the market, to trade in the market, and also be able to predict future possible movements of this market.
You can think of databases like drinking your favorite soda from a plastic cup using a straw, where you have control over the speed of the processing using your facial muscle. While stream processing is like drinking from a hose of Mountain Dew or Iron Brew, where you need to be very careful about how you approach the problem to avoid spilling data everywhere and making a mess. We are working on at the moment is how to estimate the performance of a stream processing system. So you can think of how many people you need to drink from the hose of the soda.
And the application areas I work on is brain-computer interface. So as the term itself says, it's a direct interface from the brain to an external device, which could be a computer. So you control the external device just by using your thoughts. So there are many applications that can be formed from this BCI, brain computer interface. The main use will be in terms of helping paralyzed patients, for example, controlling the wheelchair. So they just use their thoughts and then they can move the wheelchair. In this case, this person is not actually moving any of his limbs, hands or legs. He's just using his thoughts, and he's going to move this Lego robot, so which is shown here, around this block just by using his thoughts. So obviously it will be very useful for disabled and paralyzed